Okay, physical science. So this is just some more work with density if you feel like you need it. So I'm going to go through 4 practice problems with you. And again, obviously, this is on YouTube. So if you need to pause and kind of take things in, rewatch pieces of it, hopefully this will be a helpful resource for you if you are kind of struggling a little bit with these problems. So the first one's going to be pretty simple, sort of a refresh of what we were doing in class, and then I'll do some that are a little bit more algebraic. So remember, even when a problem is really simple and obvious, we should always start with writing down the givens, especially because we're also moving into using those significant figures more regularly. So writing down the numbers helps us to track all of that. So the first problem says, this is a calculating density problem. If 10.0 centimeters cubed of ice have a mass of 9.17 grams, what is the density of ice? Now, again, I know you don't have this problem right in front of you, but you are given a volume, 10.0 centimeters cubed of ice, and you're given a mass, 9.17 grams. And so we want to find the density of ice. Okay, so for density problems, we first start with our givens. So we can know a mass, we could know a volume, we could know or a density. So in this case, 10.0 centimeters cubed, that's going to be a volume, 10.0 centimeters cubed. And the 10.0 centimeters cubed of ice has a mass of 9.17 grams. And the question asks us to find the density of ice. Sorry, there's a couple spots of glare I can see right where I'm writing this, but that's a question mark. So we want to find the density of ice. We don't know what it is. Okay, so once we have our givens recorded, then we start with our equation. The density equation is always the same. Density is equal to mass divided by volume. Now in this case, because I want to find density, I don't need to do any algebra to rearrange things. I have my mass, I have my volume, so we're just going to plug and chug those values into the equation. So we say 9.17 grams divided by the volume, which is 10.0 centimeters cubed. And so we'll put this into the calculator. We've got units that are nice. We like our densities in grams per centimeters cubed or grams per milliliter. We see these two most often. And so here I'm going to take 9.17 and divide it by 10. Why am I putting that in my calculator? We know how to do that in our heads. Oh my goodness. And so this is 0.917 grams per centimeter cubed. So that's my answer. Now let's check the sig figs. We're dividing. I have a number with 3 sig figs. I have another number with 3 sig figs. So when I'm dividing, I can have 3 sig figs in my answer. And that's what I have here, 0.917 grams per centimeter cubed. Actually happens to be a little bit less dense than liquid water. Liquid water is a density of 1. And so this is why you see ice often float if you put it in a drink or a glass. Okay, so again, just kind of a refresher. This is stuff we saw in class on Monday. We write down the givens, we put our values in, we kind of check those sig figs, and we solve. Let's look at some that require a little bit of algebra. Let me grab my eraser. Okay, and I'm gonna try and shift. I'm gonna shift this over so it's out of that glare. I apologize. Okay. So the second problem says a piece of metal has a density of 11.3 grams per centimeter cubed and a volume of 6.7 centimeters cubed. Find the mass. Okay, so if we write down our givens, our possibilities are mass, volume, and density. Those are the 3 variables you can have. So we'll reread the problem. A piece of metal has a density of 11.3 grams per centimeter cubed. Okay, so that's the density. And a volume of 6.7 centimeters cubed. Find the mass. So mass is our unknown. Okay, so we record all of our givens. Now we'll write down our equation. Density is equal to mass divided by volume. So I want to solve for mass. Now, I highly recommend, because as you get older, this becomes like you must do it as you get older. that you solve this for mass. So isolate the m variable before you put numbers into the equation. I know that's a little bit different from what you're probably used to coming into high school, but keeping numbers out until the very end is the best way to do things. Okay, so I know D and I know V. I want to get M by itself. So to get M by itself, I need to lose the V. So I'm going to multiply both sides of this equation by V. I'm going to say times V times V. And what we see happen on the right side of the equation is the V's will cancel out, right? And so we said V times D, volume times density, is equal to mass. And so now we can plug our numbers in. So mass is equal to volume, which is 6.7 centimeters cubed, times the density, 11.3 grams per centimeters cubed. Those centimeters cubed cancel. I'm going to end up with a mass in grams, which seems like a good thing to do. So 6.7 times 11.3 is 75.71. Now, let's watch those sig figs. Okay, so I'm multiplying. I have 6.7, which has 2 sig figs, and I have 11.3, which has 3 sig figs. So my answer has to have the same number as the smallest. So 2 significant figures can be in my answer. So 75.71, I want to round that to 2 sig figs. And so that's going to round to 76 grams. So that is going to be my mass. Okay, so just recapping, if you're finding mass, you first isolate M as a variable, so you're going to multiply both sides by volume, and then plug the numbers in and calculate for your mass. Okay, so let's do one more, which I'm sure you could guess will have me calculating for volume. Okay, so this one says the density of brass is 8.4 grams per centimeter cubed. Density of brass is 8.4 grams per centimeter cubed. If the mass of the brass is 510 grams, find its volume. Okay, so we're given the density of brass and we're given a mass of brass, and we're asked to find the volume that mass would take up. Okay, so we have our givens written down. We again start with the equation. Density is equal to mass divided by volume. This time we want to solve for V. So we want to get V by itself. Now, when it's in the when it's down at the bottom in the denominator, you want to move it up first. So I'm gonna still, just as I did last time, I'm gonna multiply both sides by V. Okay, so I end up with volume. So I'm used to velocity. Volume times density is equal to mass. And then I'm going to divide both sides by D. Now, I know a lot of you are comfortable and could kind of do this in your head, just flip the variables. That's fine. You don't have to show me every single step, as long as you feel strong in your algebra. And so we end up saying that the volume is equal to mass divided by density. That's what we're after. Okay, so however much algebra you need to do to show that, make sure you're comfortable with the mathematical process to get there. Okay, so now we're going to plug our numbers in. The mass is 510 grams. The density is 8.4 grams per centimeter cubed. The grams cancel out, and so it's like 1 divided by 1 divided by centimeters cubed. The centimeters cubed actually comes up on top. If that doesn't make sense, that part I think it would be easier if I talk through in person with you. So I can do that on Friday, remind me. So when I put 510 divided by 8.4, I get 60 point, and it's really long. I'll just write 60.714, okay, centimeters cubed. Now, this is not the right number of sig figs. Let's look at our numbers. 510, there's not a dot after it. So 510 has 2 significant figures. 8.4 has 2 significant figures. We are dividing. Our answer can only have 2 significant figures. So if I round this to 2, it becomes 61 centimeters cubed. Okay. All right, so we kind of just walk through all the possible problem solving issues you could have. You can either be asked to find density, asked to find mass, asked to find volume. You have to know 2 out of 3 of those and just solve for the third. But let's look at one that's just a little bit more involved. It's not too tricky. So it's still the same idea. I'm going to give you 2 out of 3. But it's not as obvious what the givens are. Okay, so I'll read the word problem twice and then we'll write down what goes in. And the question is asking, what mass of water, liquid water, is needed to fill a tank 100.0 centimeters wide by 50.0 centimeters deep by 30.0 centimeters in depth? Okay, so it's a rectangular prism. Express the answer in kilograms. Okay, so we're going to read it again. What mass of liquid water is needed to fill a tank 100.0 centimeters wide by 50.0 centimeters deep by 30.0 centimeters, I forget, like whatever. Those are my 3 dimensions. Express the answer in kilograms. Okay, so we want to find the mass of water needed to fill this tank in kilograms. The volume. We don't know the volume of the tank, but I just gave you, repeated it twice. These dimensions. The tank is 100.0 centimeters by 50.0 centimeters by 30.0 centimeters. So right away, we can find the volume of the tank. This is a rectangular prism. It's length times width times height. So I'm going to take 100 times 50 times 30. I should be able to do that in my head, but I'm going to use a calculator. And that's 150,000. Now, let's watch sig figs. We've got a number with 4 sig figs, a number with 3 sig figs, a number with 3 sig figs. So our answer is 150,000 centimeters cubed if we put in our calculator. Let's write that with the proper number of significant figures, which is 3. So we can rewrite that as 1.50 times 10 to the 5th centimeters cubed. Okay? All right. So we're that part might have been a little tricky, but we're given dimensions that easily allow us to find volume. Now it's asking what's the mass of liquid water needed. This problem is assuming we know or could look up the density of water. And the density of water, if you don't know it, it's a number you should eventually get in your head. It's 1.0 grams per centimeter cubed or 1.0 grams per milliliter. You can find it in kilogram form, but we're on purpose not doing that, so they convert. Okay, so 1.0 grams per centimeter cubed. So we know our density, we know our volume, we want to find our mass. So now we're going to say, here's our equation. Density is equal to mass divided by volume. If I want to find mass, I'm going to get rid of the V. I'm going to multiply both sides by V, just like I did before. And so the mass of water is equal to V times D. So it's equal to 1.50 times 10 to the 5th centimeters cubed times 1.0 grams per centimeter cubed. And so what we have happening is the centimeters cubed cancel. And we essentially end up with the exact same number, right? Because we're multiplying by 1. If I put it properly into sig figs, the way I've been writing this here, this one has 3 significant figures. This one has 2 significant figures. So my answer with 2 sig figs is 1.5 times 10 to the 5th grams. Okay? So that's the mass of water. Now, the problem asks me what's the mass of water in kilograms, not grams. So the final step is I need to take my mass and I need to convert it into kilograms. So 1.5 times 10 to the 5th grams. If we're going to convert that into kilograms, I'm going to put the grams on the bottom and the kilograms on the top, so things cancel. 1 kilogram is equal to 1,000 grams. And if we're going to do this, let me say, I'll put the point here to keep that as 4 sig figs. Okay, so this has 2 significant figures. This has 4 significant figures. I want my answer to end up still in 2 significant figures. So 1.5 times 10 to the 5th divided by 1,000 is 1.5 times 10 to the 2nd, or you could say 150, either way, kilograms. So this is just practice with converting with the metric scale. So when we divide by 1,000, we lose 3 orders of magnitude and end up with 150 kilograms of water. Okay, so I'm going to stop there. So the second worksheet, if you're watching this before you tried the second worksheet, is just very much repetition of this sort of thing. There's definitely some conversions on there. I did one with the volume of a sphere, but I put the volume equation in there because I thought, I don't know if you know that or not, but it's like this, where I give you some dimensions and ask you to find the volume. So hopefully this is helpful, and I will see you in class on Friday.